Hi, it's Steve. I've got another problem with my lawnmower. It's not the power delivery and switch thing that happened last time, but this time, it's with this assembly right here. The mechanism that holds this blade in place and allows it to spin around. Periodically, this blade will not spin around. The axle spins, sometimes this plastic part spins, sometimes this fan spins, but the blade periodically will not spin. Now, I've tightened this bolt, I've tightened it lots of times, and that's a temporary fix for the problem, but usually this thing starts to shake itself apart and we're back to square one where the blade is not spinning. Let's take this thing apart and see why that's not working. So I'm going to go ahead and tighten this bolt down. This is a 19mm bolt, and I want to demonstrate that I can get this blade to move without applying that much torque on it. So if I hold this thing steady, and I'm wearing gloves for a reason, so I don't cut myself, but if I put torque on the end of the blade, you can see that it spins quite freely without spinning the fan part as well. And that's not necessarily a good thing because we want this fan to spin while the blade is spinning as well. It's supposedly supposed to cool the electric motor down that's underneath this piece of plastic. So another thing I'm going to demonstrate is how this can knock itself out of alignment, how the blade can knock itself out of alignment just from regular use. The motor generally applies a torque in, I think, this direction, and then when you release the handle that's providing power, the motor actually spins in the opposite direction to try to stop the blade from spinning much faster than it would naturally do just by friction alone. So you have motion going in both directions, and this thing shakes around quite a bit. Let's see if we can demonstrate that issue. So we can see from just that short amount of time that this was spinning around, the plate and this piece of plastic underneath the plate have knocked themselves out of alignment from the orientation of this blade. That's exactly what I wanted to show. And the bad news is that the energy that's being created by the motor is not being directly transferred to this blade. Otherwise, this would not have knocked itself out of alignment. So we're losing a bit of energy because of this looseness or whatever this is not doing to grip this assembly, and because of that, over time this is going to get looser and looser, and eventually the blade is just not going to spin. So I want to inspect these parts under a little bit closer on the table. We can see why they failed, and then we'll get some replacement parts if they're damaged, install everything, and hope that that will solve this problem. So I should have mentioned this earlier, but before you start putting your hands inside of a lawnmower, especially the blade assembly, if you value your fingers, it's a good idea to turn the power off, make sure there's no way electricity can get into this thing, and then you'll be safe and you'll be able to carry out these repair projects. So here is looks like a washer, a rectangular washer of some kind, and then there's a piece of plastic that's pretty beaten up. Then we have the blade, and the blade should come straight off, and it does. And then we have this thing, which is the fan, and yeah, that's pretty beat up. And then we have a washer. I don't think we'll need to inspect this. I'm only interested in the other parts. This is just a bit of a spacer, I think, to keep the fan from making contact with the housing of the motor.
Okay, and here are the old parts which have just been removed from the mower, and here are the new parts for comparison. And you can see just from this fan alone that there is a lot of damage to it. It's missing many of its blades, and I think that may have contributed to the overall problem. Here is the new fan, 8 blades, nice and tidy, nice and clean. And this piece here, this is called the blade insulator. It sits between this middle bracket, which goes on top, and the blade, which goes underneath. And it's held together by that 19mm nut. Now, on close inspection of this part, you'll see that there's a lot of damage to the edges and a lot of pieces of plastic have broken off. And on the back side, we can see that the plastic is very smooth. There's a lot of evidence here of melting. You can see these circular lines that are going around the center of the part. And I suspect what's happened is something became loose and this part started to move around, or something moved around on top of that, increased the friction, increased the heat, and the melting started, and that problem just compounded itself over time. Here is the new part for comparison, and you can see that there are two ridges on this side. In fact, if you look at the old part, you'll see that there are ridges on all four sides, and I'll explain what those do in a moment. And when we look at the back side, hey, it's not melted at all because it's brand new. But these ridges, they go in the perpendicular direction. So these ridges are going this way, and when we flip it over, they now go this way. The intent of these ridges is to hold this bracket and the blade in place and prevent them from moving independently of the spin of the motor. When the motor's axle spins, it will try to spin this plate, which is now locked in place by these ridges, and that means that these parts can't spin independently of one another, unless of course this piece of plastic gets damaged as we saw earlier. Now we can take this idea one step further, and we can introduce the blade like so. And now the ridges on the back of the plastic blade insulator will prevent the blade from slipping as well, just like it does for the plate on the other side. Okay, now the next component of this assembly is the fan. And the fan's intent is to cool the motor down while it spins. Now, because my old fan part has several missing blades, it's pretty clear that it may have contributed to the overheating and then caused this melting and mess to happen on the blade insulator. The cracking of the plastic probably happened when I over-tightened things, but I suspect the integrity of the plastic was probably weakened by the melting that happened beforehand. Now, when we look at this blade, there's nothing really in place that prevents it from spinning independently of the fan. But I think that's intentional, as we can see that once all these pieces are assembled together and this bolt is sufficiently tightened, then the blade and the fan are held together by friction. Now that's not ideal, there's probably a better way to design it, but it's good enough for this. Okay, so I think these replacement parts will solve my problem, and it will at least prevent the blade insulator from slipping around on top of the blade. So let's get these components reassembled with the lawnmower and give things a test.
So as they say in all of the repair manuals, installation is the reverse of disassembly, and that can't be truer for this project. So the first thing we need to do is put the fan back on, followed by the blade and the blade insulator. The blade, take a look for the sharp edges, that is the bottom side. So anything that's tarnished like this, that is not looking like it came out from a factory, is going to be the top. And this is the bottom, the blades are nice and clean, and in fact I had sharpened these a few weeks ago, so I know this is the bottom side. Alright, put the blade on, doesn't matter which way it goes on, as we know there's nothing to lock it in place. And then the blade insulator, mine, as I mentioned earlier, only has ridges that are opposing each other perpendicularly on both ends. If you have an insulator that has 4 ridges to lock the that metal plate in place, that's the top side. In my case, it really doesn't matter because they're symmetric depending on which way you look at this. So I'll put this on this way. And then next up is we have this metal bracket. Don't think it matters which way it goes on. It's just there to support everything in place. And as you can see, the orientation of the axle is only allowing me to put the bracket on in this direction. I cannot turn it anymore. So that means I have to rotate the rest of the assembly so that everything gets put in the proper place. Okay, that looks pretty good. And finally, we can put everything together with this nut. Alright, that's pretty tight. We'll probably do a bit more. Yeah, let's put the motor on and let's see if this thing starts to shake itself loose just like last time. Hey, so that is looking pretty good. Once I review the video footage, I'll check to see if it actually spun around as a unit. And although if it hasn't, I'll probably tighten this a little bit more, maybe with a bigger wrench, and that should lock everything in place. So that was an easy fix for this, and that's going to wrap things up for this project. If you're interested in getting these repair parts, namely the fan and the blade insulator, I'll have a link below in the description where I purchased these. I think I got them from Amazon or eBay. In any case, I spent maybe less than $20 US at the time to purchase both of them. So that might be something inexpensive for you to purchase should you need these parts. So that concludes another repair project, and as usual, I hope you found this presentation informative. I hope it also helps you fix your lawnmower too. Thanks for watching, and we'll see you next time.